Okay, so before we actually get into this lesson, we're going to talk a little bit about what the expectations for your paper in front of you should look like. So what should be on your paper? You're going to want to include your name, your date, the subject. So for your class, it's going to be Algebra 1, what period you're in, what kind of activity you're doing. So today you found this activity on Edpuzzle, so you'll write that on your paper, and then what the actual lesson title is. Underneath all of that, labeling, you're going to have all the examples that I am doing in my notes also on your paper. So you're not just watching this video, you're going to be treating it like you're using your notes in class. You're going to be writing down every single thing that I write down on the screen. And then you're going to include all your work for any of the Edpuzzle questions. So throughout this video, it's going to pause your screen and it's going to pop up with a question. All the work that you're doing with that question is going to stay on your notes paper as well. And then just make sure that you keep this paper somewhere handy, because you can be asked to send me a picture of your work to receive credit for this Edpuzzle at any time. So keep it somewhere that you can easily find it. So your lesson title for today is going to be 1-step to 2-step equations. We're going to start out with 1 step just to give you a review, and then we're going to make it a little bit trickier by involving 2 steps. Your learning targets are I can solve 1-step and 2-step equations. I know I have it when I can use inverse operations to solve for a variable. You're learning this because solving equations can help you identify a missing value. So for example, if you have a rental car and it's going to cost $20 initially, and then it's going to cost 10 cents for every mile you drive, and let's say you want to know how far can I get if I only have $50, you could solve an equation to help you figure out exactly how many miles you're going to be able to go in that rental car. Here are your first 2 examples for 1-step equations. I have x plus 6 equals 11. Whenever I'm doing equations, I like to draw a line down my equal sign. That way I can keep the left side organized and away from the right side, and it's just easier to visually see everything. So whenever you're doing these, your goal is to get this x piece by itself, because we're trying to figure out what value, what number right here is going to make this a true sentence. So what plus 6 equals 11? And you may be able to do that in your head right now, but we're going to actually solve it with work. So we're going to get this variable, this letter by itself. Right now, 6 is being added to it, so we need to do inverse operations. And what that means is we're just going to do the opposite. So since 6 is being added, we're going to subtract 6 from both sides. The plus 6 minus 6 cancels each other out. There's nothing there. All I have left over on the left side is my x, so I'll bring down the x equals 11 minus 6 on the right side gives me 5. So x equals 5 is my final answer. And then you can check back up at the top. Does 5 plus 6 equals 11? And yep, if you plug in a 5 right here, it does work. For B, you're going to be doing the same thing, but it's in a little bit of a different order. So I have negative 11 equals 17 plus y. This time my letter's on the right side, but that's totally fine. I'm still going to start by drawing a line down to keep things organized. If I want to get this y all by itself, I need to get this 17 to the other side. Since 17 is positive, I need to get it to the other side by subtracting. Minus 17, whatever you did to the right side, you have to also do the left side to keep your scale balanced. 17 minus 17 cancels out. That was the goal. I have just a y left over on my right side. And negative 11 minus 17 more leaves you at negative 28. So negative 28 equals y. Here's an example for you to do on your own and actually type into Edpuzzle. So you have 4 plus x equals 6. I want you on your paper to solve this using inverse operations, and then write your final answer as x equals into Edpuzzle. Okay, so you should have started this problem by drawing a line down your equal sign. Your x is on the left-hand side this time. You want to get the 4 to the other side. Your 4 is positive, so you need to subtract 4 from both sides. x will equal 6 minus 4, leaves me with 2. Still on one-step equations, this time I have 5 equals negative 2 plus a. So I want to get that a all by itself. That means I need to get this negative 2 to the other side. Since it's negative, to get it to the other side, I need to add 2. Negative 2 plus 2 cancels out. We're left with just a on the right-hand side. 5 plus 2 on the left gives me 7. And remember, you can always go back up and check 5 equals negative 2 plus 7. Negative 2 plus 7 does equal 5. And then for part D, draw the line down. 7 minus 10 equals 35. We want to get z all by itself, and there's 10 being subtracted from it right now. So to get the 10 to the other side, since it's subtracting, we need to do the inverse. We need to do the opposite by adding 10. Minus 10 plus 10 cancels out. We have z left over on the left-hand side equals 35 plus 10, leaves me with 45. Go back up to the top, check 45 minus 10, does that equal 35? And it does. We have E and F now. So right here we're given negative 39 equals negative 3t. When we're looking at this t all by itself that we want to get, when we're looking at this, we want to get the t all by itself. So I need to get this negative 3 to the other side. When a number is connected to a variable, a letter with no symbol in between, that means that the negative 3 and the t are being multiplied. There's an invisible multiplication symbol right in there. So if we're working with inverse operations, we have to think to ourselves, what's the opposite of multiplication? So the opposite of multiplication is division. So we're going to divide this negative 3 off of the t. Since we divided it off on the right side, we have to divide it on the left side. Negative 3 divided by 3 cancels out. You have just a t on the right. Negative 39 divided by negative 3 leaves you with a positive 13. Negative divided by a negative turns positive. And then we have f. I have x over 5 equals 6. When you're looking at this fraction of x over 5, that's really the same thing as saying x divided by 5. So if we want to get this 5 to the other side, the opposite of division is going to be multiplication. Times 5 times 5. 5 over 5 cancels out, and you're left with x equals 6 times 5 gives me 30. Go ahead and complete this example on your own. Negative 10a equals negative 150. You should have started out by dividing both sides by negative 10 to get the a by itself. A equals negative 150 divided by negative 10 gives you a positive 15. All right, and now we're on to our two-step equations. So looking at A, we have 2r minus 14 equals 2. You're again going to start out by drawing the line down it. Our goal is to get this r piece by itself. So I want to move everything to the other side first. So when I'm looking at the piece that's not connected to the r, I see a minus 14. So we want to get that 14 to the other side. Since it is being subtracted, we're going to do the opposite, and we will add 14 to both sides. Minus 14 plus 14 cancels out. On the left-hand side, we're left with 2r. On the right-hand side, 2 plus 14 will give me 16. And then these are two-step equations, so we're not done yet. We have to do our last final step. I have 2r, that's like an invisible multiplication symbol in between the 2 and the r. So to get the 2 to the other side, we need to do the opposite of multiplying. we need to divide both sides by 2. And you'll be left with r equals 8. Next up, we have b, 12x plus 36 equals negative 12. Again, we want to get the variable all by itself. So I want to get this x piece all by itself on the left. So I need to move 36 to the other side. 36 is positive, so I'll do the opposite. I will subtract it. 36 minus 36 cancels out. I'm left with 12x equals negative 12 minus 36 leaves me with negative 48. I want to get the x piece all by itself. Again, 12 is being multiplied by the x, so I need to do the opposite and divide it off. X equals negative 48 divided by 12. Leaves me with negative 4. Go ahead and try this example. You should have started by adding 6 to both sides. You'll get 3x equals 15. Divide both your sides by 3, and you should have x equals 5. And then our last 2 examples before you finish your last ed puzzle question. Draw the line down. These are still 2-step. This time I have 12 equals negative 18 plus 6b. I want to get this b piece by itself. I see right here I have negative 18 that I want to get to the other side. Since it's negative, I'm going to have to add 18 to both sides. 12 plus 18 gives me 30 equals, I have 6b left over on the right. I want to get this b by itself. Right now 6 is being multiplied onto it, so I need to divide the 6 off. And I should get 5 equals b. And then finally I have negative 55 plus 11x equals 55. I want to get the x piece right here by itself, so I need to move the negative 55 to the other side. It's negative, so I'm going to add it to the other side. That leaves me with 11x equals 110. I need to divide the 11 off, and I will get x equals 10. Your last example to complete on your own. So you should have started by subtracting 10 from both sides. You'll get negative 11y equals 44. Divide both sides by negative 11, and y will equal negative 4.